Hi and welcome to Detect Worst Performing SQL Queries Part 3. We'll continue to what we covered in Part 2, and there are some very important concepts. I'll be clearing it in Part 3, and we'll continue with how to capture the disks, related queries, the top network queries, and finally how to find which queries are running between a particular hour. Or say you have a production issue and you want to know what's going on our SQL Server, you can check, run that particular set of code, and it will tell you which are the queries are getting executed, how much time they are taking, so you can concentrate on them, and if anything looks abnormal you can just go ahead and fix the issue pretty quickly. Let's quickly cover the presentation part of it. My name is Prakash and I work as a Senior Infrastructure DB at Advanced Software. You can visit my blog for sqlfeatures.com for all the scripts and this video. You can connect me on Twitter, email, Facebook. So our agenda, in last sections we cover top CPU consuming queries, we cover the basic concepts of what we are doing at, and today we're covering the next two part, plus we will be covering this particular area which says which queries are using most CPU in last 30 minutes, and I'm sure you're gonna love it. So let's jump on it, but before we go further, there is a change in the slide which I showed in the last session, and if you notice the change, it's about this query cache column. So this particular field has been added in SQL 2008, and this is a very important field. It will further refine the result set what we achieved with top CPU queries. So we'll talk about that later. We already covered this. In case you're not clear up to this screen, then check the video 2 of the series where I have covered this in detail. Alright, let's move on to demo. Here's top queries screen. Let's start quickly with the top queries preparation code what we covered last time. As you can see, I made some quick changes to it. We continue to have the DB stuff database. If you don't have it, go ahead and create it. Here is the first script which you have to run to start this process. Here is the procedure, proc generate load. What it does a select of 320k rows on this particular test table and then delete rows from this table. We will be using this stored procedure with the combination of a batch file to generate the load, and so we can see multiple scenarios. So this will just create some test data for test table 4, so keep it running. Keep an eye, if this code takes a little bit longer, you can cancel it at any point of time, but there will be a lot of rows inserted by then. Finding top CPU queries, we covered it in last exercise video, and make sure you go and watch that again, but I'm going to cover some of the key changes I implemented since our last thing. One, I have used the variables to filtering the criteria. So in wherever we are converting it to milliseconds, filter more than milliseconds. Alright, so this particular variable will be using if we are looking for queries which are taking more than a particular amount of milliseconds. So right now it's set to 1. If you want your, depends on the results, you can increase it. Filter hours, how many hours of data you want to filter, and this is for the first time when you're running the query. You might want to take here a right value so that you can have a good baseline. Execution count. Now if you look at the execution count, what you're seeing here is the value is 2, so I'm trying to get any query which has more than 2 execution count. And the debug flag. The way debug flag is used is the moment the value is 1, it start printing out a lot of debugging data so that you can see what's going into the query and to it. Here are some of the variables we are printing. If debug equal to 1, then up to this part the code is almost same. I did added a is null clause here just to make sure that if there is a null there, in that case the query is not failing. Other changes which I have done is that rather than doing the average CPU here, I'm continuing with the raw value here, and we are moving it into the table to another statement. We are covering plan handle and SQL handle, putting this data into a temp table which will process it further, but there are changes in the where criteria. What I made is that as you can see, date filter is based on the filter hours, so that you can tune it as you want, and then we are trying to group and trying to find basically the top query hash values. Now this value is changed compared to what we have seen in the previous example, and I'll show you the reason why it is changed and how it is more helpful to get the right data. Now after that, we are again printing the value. If debug is 1, in that case the data will get printed. Now again I'm summarizing the data for all the various max criteria, and here we are creating the average CPU time as needed. So it will go to set 2, and then we publish this data. So let's see what's the current stats on this server. So I run it time. There are so many queries running and returning. As I can see, the queries which I'm interested in are the top 3, which we checked last time, and they are taking more than 3 seconds. These are the 3 statements which we'll be generating and testing and how it is happening. Here's the execution count. As you can see, there is a query hash value which is important, and we'll see why in a matter. So let's start. To clear up the values, I will be starting the SQL Server. Alright, so SQL restart is done. Now what we'll do is we'll go ahead and generate the load. While this load is generating, let's go through it again. What it is doing, we are trying to insert into a test table set 4, 290, 300, 310, 310, 310 and 310, almost 6 statements we are doing it. Now we are calling the proc generate load state procedure. If you remember, this procedure is doing a select of 320k rows, and then it's deleting the data. This delete statement, it's running. The idea is the delete statement is getting executed in this procedure and then getting executed here. If you remember, last time this statement was not there. I just added a comment here to show a particular thing, which we'll see now. Let's see if the procedure is executed. It's still going on. So once this is completed, what we are expecting is we should see 6 insert statements, and procedure is doing select, so we are calling procedure 3 times, so 3 select statements. We should be seeing 6 delete statement, 1, 2, 3, and then 1 in each time the procedure is getting called. So 6, 3, 6 is what we are looking at. So the procedure is still getting executed. Why? How about we execute it and see how it's looking? So as you can see, we are starting seeing the right data what we are expecting. The statement got executed 6 times, 3 times, delete is 5 times. So most probably right now the last statement was running, which is completed. Let's refresh it. And we are seeing an exact 636 what we are expecting to see. Let's look into why query hash works, how it works. What I'll do is I'll enable the debug flag, which start pointing out a lot of data. So this video is in 720p. If you're not clear, you can move to convert it to 720p, and then you can see it. These are the values by which we are trying to get this data. Now this is an intermediate table. This is the table. If you look at after the first time we summarize the data, from set 1 it is coming up, right? So debug flag is 1, so it's printing it out. As you can see, there are multiple delete are there. In the last exercise you did notice there were 2, and this time I did make a change to show a concept why it is there. So you see delete test data is there, then delete from test DB. These two are prepared statement because they got executed from the batch file directly, while this one is showing the database name because it was executed by stored procedure proc generate load. And so you can see it this way. This is coming as a 3 different rows, even though they are basically doing the same job. It's the same query, no difference. One time it's getting executed from procedure, and one time it's getting executed from ad hoc, and third time it has extra command. And what basically happens, the way SQL Server handle is that if we rely on SQL handle, it is gonna give 3 different hash codes for it, and which is not good, which means if we look at the counts of it, there are 2 execution counts of first statement, 1 of this and 3 of this. If you're putting a criteria of more than 2, then probably we'll be able to get this, but then we don't know that this executed also 3 times. So this is why we need to summarize this data to get a common output. Now how to do that, here is a new column introduced in SQL Server 2008, which is called query hash. Even though the plan handle and SQL handle is different for this same query, this query handle is exactly same. This query hash is exactly same, right? So it's pretty easy to identify, use the query hash to summarize the data so that we can get much better. The same you can notice the insert test table set for, right? So we are doing 290K, 300K and 310K records in this. And for SQL Server, these are 3 different query execution plan. But if you look at the hex values of this is same. So again, this can be summarized and we can get a better number of basically 1, 1 and 4. So all we want to see is give us the total number is 6 times it got executed. We don't care whether it's got executed by a stored procedure or ad hoc or a different. These are the cosmetic changes or a variable value was changed. So this is a very important column. So what we are doing is, once the data is collected into this table, we are doing a summary of that data, and based on the query hash, server name and runtime, which we all know that all 3 will be the unique, and we want to group on based on that, and then we are just showing the data. Now here when you see the data, you are only and only seeing the inserted statement 1 time with the execution count 6. So now, irrespective of this procedure is getting executed in different fashion with number of records different, so variables values are different, you can still figure out a much better way that how many times this kind of a statement is getting executed. Delete, as you can see, the delete was Pretty has an additional command itself make it to have a different SQL handle, which is why we were not able to summarize it before. Now with that, delete is coming as a total 6, and delete does get executed by procedure and then ad hoc, and we want to summarize all of them because our idea is to find that particular query which is taking time, so we can tune it and see that if there are any kind of tuning needed on that particular query. Alright, so these are the basic differences in what we covered in the last session. Let's continue with the top disk queries. The concept is pretty much similar, the same set of variables we have. These variables are used when we are trying to convert to milliseconds and adding the filters. Now in this example, since disk has 3 different variables which we'll be talking about, let me execute it to show it to you. There are 3 different kind of disk related values are provided by the stats table. One is total physical read, total logical read, total logical writes, and these 3 statements is what we are trying to find. Now I wanted to find the top 100 statement for each of these so that we can tune it properly, and then out of this top 100, if any of them are getting duplicated by another criteria, like something as like top average logical reads as well as average logical writes, so we'll get it summed up, and then we'll, for this particular query hash value, ideally that should be 300 if they're all distinct, but we are doing a distinct to get the real values what we wanted out of this table. And once the table is there, the values are into the first set of table, then we are summarizing the values to get the summary and removing the duplicates, merging the duplicates into the real values. And we are seeing that there are 6 execution count of insert statement. Average total physical reads are 3 each time. Average total logical reads are 3308. Average total logical writes are 8. While for select statement, the execution count is 3 times. Logical reads are 2. Average total writes are 0. So this looks like pretty good statement. The same way delete get captured as well. As we can see, there are mostly logical reads here and logical writes on delete. So that sums up the top disk queries. That's how you can sort based on average total reads once you have the output, or physical reads, and you can see which queries are taking most of the time on your system. So you can concentrate on fixing them. Now let's look at the network queries, and I was telling you that in SQL 2008 R2 there is a new column got introduced which is called total rows, and this is an amazing value. This provides you how many total number of rows got returned by each and every statement getting executed in query stats, and this makes it a very easy way to find how to tune your network to see if there are any queries which are getting executed and returning more than, like, say 100 rows. If they are returning more than 100, 200 or maybe 400, you can start working on seeing to tune those queries. Maybe there are some reports which are returning 10,000 rows and showing only 100, so you can tune them. Your network traffic can be looking pretty good. And we run the statement, so let's see how much rows get impacted by those statements. Well, again, those 3 same queries are coming. Average total number of rows is 1919. As I have divided it by 1000, which is wrong, we didn't have to do that. So what I'll do is I'll do not need to convert it to millisecond because this is a count. So I changed it. Let's execute it. I mean, this is the exact total rows count what we are seeing there. As the query itself, as you can see, trying to say 310k records, but actually there is only this many records, so that's why we are seeing actual rows count. And table set 3, we are seeing the right amount of 320k rows on an average. Execution counts are as usual, query hash is matching, and the procedure why it is coming. This value is what telling you that what kind of network traffic you are hitting, the queries are hitting. Sort on this and you can figure out the top, maybe top 20, top 10 queries which are returning average total rows very high, and you can talk to the developers to get it fixed and make it work better. So now we are going to talk about a very important topic called this script, which collects 2 snapshots of queries, texting SQL Server CPU within 5 minutes. Our idea of this exercise is basically to check which queries are getting executed in a particular 5-minute, 10-minute or 30-minute duration. So you have a production system, sometimes you'll find that suddenly the system is running very slow, you have no idea what's going on, and basically SQL DBAs, since they are mostly don't understand the functionality, in that case they are like, okay, what do? I can see some queries, but I couldn't make out whether they are the ones causing this delay or not. So this script will help you to figure out exactly that logic and teach you how to read this data and how to process this data, and show you in a very good format where you can quickly understand that which queries are texting your system within that particular peak duration. Say right now you have a system load. What you will do is, currently I've set it for 5 minutes. If you decide to change it, you can go ahead and change this value from 5 minutes to whatever the time. So what we are doing is we are running exactly the same find top CPU queries in the set 1 and the same in the set 2, but between that we are making a wait for delay of 3 minutes. You can change it to 5 minutes, 10 minutes, but for our exercise 3 minutes is sufficient. And now what we will do is, there is another change I would like to talk about, that I am truncating the value of this collect top CPU queries and then inserting it first set of data into this and then inserting the second set of data into that. And then in the next query, find top CPU and peak hour, we will see how this gives us all those queries which we are looking at. Alright, so I'm gonna execute this and then I'm gonna run the load again. We know that our current execution count is 663. If I run the same batch file again, it should be 12.12.6. Alright, so let me close these windows just to be see query. So we have a wait time, so we execute it within few seconds. Within first second it actually did it. It will run for 3 minutes. So now it's waiting. What we will do is we'll execute the collect statement since it took the first load. Now the second load should make the count to 12.12.3. But meanwhile, rather than waiting, let's go and check into the next query what we are doing here. So what I'm doing is I have done two set of data, two set of snapshot into collect CPU queries, right? So first and then after 3 minutes again, and within that 3 minutes we are executing these statements, and all we want to know is that we want to find out those 663 statement that which are getting executed in those last 3 minutes, so that we know that these are the statement currently running on the system and causing any kind of performance issues if there are. I have this generic query where I usually put the machine SQL Server name, so please do that. And once that part is done, we are collecting max runtime logic, and basically trying to see the first snapshot, current snapshot, and the last snapshot runtime, and then we are inserting the data into it, and which is what making it pretty useful, right? So select for compare. Now we are collecting the data from first snapshot of this table, putting into a before table and then after table, and then finally we are summarizing the data. And in the last step, we are trying to find the difference of first snapshot and another snapshot, which will tell us what queries we are getting executed. Alright, so almost getting 3 minutes. The query should be over. Yep. So it does the two snapshots. Let's close this. Our work is done. What we'll do is find top queries in peak hour. We want to find out how many queries got executed in last 3 minutes. So as the first statement, I'll just execute it particularly so that you'll see what it is returning. It's saying that first snapshot was around as 2006, the another was at 23, exactly the 3 minute difference what we were expecting. Right, so during that 3 minutes, as we can see, these are the statement. It captured it. Seems like this statement did get executed one time. Same plan is 75, and now this is the average CPU time we are getting. Now this is the average CPU time difference between the first snapshot and the second snapshot. This column shows total number of execution plans, and this column shows the difference in the execution plan. This is an important column. This is the one telling us that this statement got executed 6 times between this time and this time. Right, so two snapshot, we are capturing the data for those two snapshot. Delete got executed 6 times coming from this procedure name. Now one thing to understand, since we are summarizing it and maxing out the object name, it might be a mixture of a stored procedure and ad hoc statement if the same statement runs the same way the way we are testing in this exercise. Once you find this code, all you need is to get the query hash value for this, and you can literally see how many times get executed, who is executed, and whatnot. Let's look into the second statement is top. Again, the top, we know that we changed it to top to 320, 330, and 310. So we just pick the max value. Again, it's showing us that it got executed 6 times and the select top executed 3 times, and that's the exact output we were expecting for this exercise. So I hope this queries are gonna help you to figure it out. In case you have any production issues or something, just execute them one by one in the same sequence, and you'll be able to see what's going on. Share these queries with your developers, and they'll be able to figure out why it is happening, what it is happening, anything is unusual or normal or expected, and so you'll be able to have a much better understanding how the system is working. Alright, that concludes today's session. Okay, to download queries, you can visit my blog with the look for the post Detect What's Performing SQL Queries Part 3, and if you go a little bit down, you can see that these are the scripts what we have used in this exercise. Download it, test it, let me know how do you like it, post your comments. I'll look forward to hear from you. This concludes our today's session. You can subscribe me on YouTube at SQL Features channel. You can subscribe me on my blog, connect me on Facebook, Twitter, and what are the other things you want me to cover in future articles and future videos. Thank you for watching again.